Have you ever wondered how doctors can see not just what your organs look like, but how they're functioning? How they can pinpoint a tiny cluster of overactive cells hiding deep inside the body? The answer lies in a remarkable piece of technology called a PET scanner. Today we're going to break down exactly how it works, from the tiny radioactive tracer you're injected with to the detailed 3D images that help save lives. Unlike an X-ray or CT scan that shows structure, a PET scan, or positron emission tomography, shows metabolic activity. Think of it like a power map of your body. Areas that are using more energy, like your brain, your heart during exercise, or rapidly dividing cancer cells, need more fuel. For a PET scan, that fuel is a special kind of sugar called FDG. But this isn't ordinary sugar. It's combined with a safe, short-lived radioactive isotope. This creates a radioactive tracer. Once injected, this tracer travels through your bloodstream, and hungry, active cells absorb it more than slower cells. This is where the real magic happens. As the radioactive tracer decays, it emits tiny particles called positrons. Inside your body, a positron immediately collides with its opposite particle, an electron. This collision is called annihilation, and from that collision, two high-energy photons called gamma rays are produced. Crucially, they fly away from each other at the speed of light in perfectly opposite directions. You lie on a bed that moves through the scanner, which is a large ring filled with incredibly sensitive gamma ray detectors. These detectors work in pairs. They are constantly listening. When two detectors on opposite sides of the ring are hit by gamma rays at the exact same time, a process called coincidence detection, the scanner's computer knows that the annihilation event must have occurred somewhere on a straight line between those 2 points. By collecting millions upon millions of these simultaneous events from every possible angle, a powerful computer can triangulate the exact origin points of all this activity. It builds a precise 3D map showing exactly where the radioactive tracer, and thus the high metabolic activity, has concentrated. The result is an image where bright spots like these indicate areas of high activity. But to know exactly where that activity is, PET scans are almost always combined with a CT scan. The CT provides the detailed anatomical map, the bones and organs, while the PET overlay shows the functional activity. This allows doctors to see that a bright spot is, for example, precisely in a lymph node or a specific part of the lung. For a patient, the process is straightforward. You'll prepare, often by fasting. A small amount of the tracer is injected into your arm. You then rest for about an hour while your body absorbs it. During the scan, you just need to lie still as the machine does its work. The radiation exposure is low and considered very safe for this diagnostic purpose. So, to recap, a radioactive sugar tracer is absorbed by active cells. It emits positrons that annihilate with electrons to create gamma rays. The PET scanner detects pairs of these rays to map their origin, creating a functional 3D image of your body's metabolism. It's a brilliant fusion of biology, physics, and computer science that gives doctors a powerful tool to diagnose cancer, heart disease, and brain disorders. If you enjoyed this dive into medical technology, hit that like button and subscribe for more. Thanks for watching.